Alright guys, so I'm finally going to get around to setting up my ground mount solar. I've been sitting on this project for a year. I actually bought all the equipment a year ago. It's been sitting in my garage and I just haven't been able to get to it. So finally I get a chance to get going on this thing. So let's get right into it. So it's going to be, I'm adding, for those of you who don't know, I already have a system that has 8,800 watts. And it's on the garage roof. So I've already got the whole system battery backed, and I'm just adding 4,440 watts onto a ground mount system. Okay, so we're going to be adding that on. I'm going to keep the same battery bank. It's lead acid, 16 Trojan, or the L16RE-Bs. 16 of those, 740 amp hour battery bank. I'm currently producing about 32 kilowatt hours a day, and this should add maybe up to 16 kilowatt hours a day. And of course, depends on how much sun you get. We burn through about 50 kilowatt hours a day in our house. It's going to be an IronRidge ground mount, and it's going to be facing southwest. So I'm not even really trying to maximize the power out of this. It's not how much power you get, it's when you get it. So the point of this is to extend my solar day. I want to get power later in the day, so I'm pointing this a little bit to the west, and I'm putting it at a place that gets sun later in the day, and mostly during the winter months is when I have a problem. During the summer, the sun's straight up overhead and we get sun all day. It's not a problem, but well, we'll get to this in a second. But there's a tree right here that blocks my panel in the wintertime around 2 o'clock. So way over here, we'll get sun. This is the west over here, and this is the south over here. So, as you can see. So this gets sun later in the day and good in the wintertime. That's just a close-up of the existing system. You can pause that if you want to take a look. And here's what I'm adding. So I got this panel out here. It's about 14 feet by 20 feet. I got the combiner box right at the panel, and then I'm running 130 feet of combined power up to the same power wall that I already have. Take a look at that. I'm just adding one PT100. I already have 2 of them. And this whole system is so easy to scale. I mean, I think you can put up to 8 of these on here. And everything else is just the same, pretty much. I'll just be bringing in more power, and then later in the day when these 2 have checked out, this will keep going. Keep me going. I got the 2 inverters right now. You can go up to 4 on this system. So I'm at 8,800 watts, and you go to about, I guess, 18,000 watts or so if you had all 4 of them. And that's continuous. The peak is double that. All right, so I'll just be adding that. Some of the stuff is just old stuff from my old system. I have like 40 or 50 videos that show step by step the entire process of how I built that original system, and I describe this whole diagram and a bunch of other stuff in that. You can look under my playlist. You'll find it under solar power. I can do a quick rundown here. The power comes in the solar panels, goes to a combiner box that runs up to your charge controller. It goes into the DC breaker box. Power then flows and charges your batteries. Power flows out of the batteries and up into however many inverters you have. I have 2. That converts that 48 volts DC into 220, 110, 220 on the AC side. That goes out to a transfer panel. I have 2 of these actually, and there's 10 switches on each panel. So 20 circuits in my house are powered by the solar and by the utility at the same time. At least, I mean, the box is powered, and so you can switch them. I could have 4 rooms on solar and 4 rooms on utility, or any combination, which is a great feature. I really like that. I also have another transfer switch on this side where incoming from the utility, or I can switch to a generator. So I mean, you could be running off generator and solar, or utility and solar, or batteries, or there's just all kinds of possibilities. So this is the this shows basically how I selected the wire and the breakers that I used, and I've updated this a little bit, but I just look at how much current is in there, if it's in an attic, if it's in conduit, and you figure out what, you know, what size wire you need and so on. And this is what I actually picked for all these different things. I'll be using a lot of the same stuff. I'm going to skip over all this for now. Yeah. All right, so a little more detail on the panels. I got 12 of these quantum panels, the Q-Peak LG 4.2. It's a 370 watt panel. I think I paid about 60 cents a watt for these. I think there's stuff out there now you can get for 50 cents a watt. It's a year later now. Anyway, there's all the details here. It's 72 cell. I think they weigh about 50 pounds, yada yada. Here's more information. This gives you all like the, you know, all the details. We'll get into that later. I'm going to use that to size the number of, oh, and it's later. Here we go. So I've got this spreadsheet that I wrote, and I'll link it. You can download it if you want from the link. Use at your own risk. Okay, it could have problems with it. I don't know. I think it's okay, but I use it. But use it at your own risk. There's 4 sections. The first section here is your solar panel. So you can plug in all the information for the panel that you happen to be using right here, including stuff like your open circuit voltage, your short circuit amps, even your temperature coefficients, right? Plug all that in. You can put in your cost if you want. The second area, you don't plug anything in here. This is your array. It'll all be calculated automatically. Over here you have your charge controller information. So I'm using the PT100. It's 6,600 maximum watts. Its operating voltage is 187. So, you know, it's 100 amps charging. And then this last section is the design check, and you're not going to enter anything in here. So the only place you're putting your data is in your controller and your panels, right? Then what this does is, and I'm actually going to switch to the actual spreadsheet, which is this guy. So now you can go in and say, well, what if I had 2 in series and I had, you know, 3 strings, and then it'll automatically calculate how many watts you got, what's the you know, the VMP, your maximum voltage. This is at the coldest temperature. You're also going to plug in your temperatures for the coldest temperatures for each month of your location. And this will assume the coldest temp, you know, bright sunshine, perfect angle. What's the highest voltage you could possibly see is 106. That's less than 187. By 80, you got 80 to spare. So your design check says no problem, you can do 2 and 3. Well, we're going to try 3 and 4. Okay, now we're up. This is what I'm going to do, by the way. So it's 159.9 versus 187. So I still got a cushion of 27 volts. And I look at my currents, I'm 76 versus 100, so I got a 23 cushion there. And I'm under my max watts by 2,000. So design check says fine, go ahead and build that. Now let's try, what if we had 6 strings? By the way, in parallel, ups the current. So you see how the current went off the chart now, right? It's over 100, and that's a problem. You can't build that. So let's go back to 4. And what if we went 6 in series? Okay, that affects the voltage. Now we're at 319 volts, way too high. That's not going to work. So we're going to go back down to 3. No problem. Anyway, you can play with that and help design your system. It does some other stuff. I wouldn't rely on this too much. It's just maybe one more check of your own work. This calculates what the max current is in certain wires, so you can size the wires and the breakers and stuff like that. All right, so let's look at the ground mount racking system. I'm using the IronRidge. So what you're going to do is go out and you're going to source your own pipe, right? Get it locally. There's no reason to have them ship it from IronRidge. But what you're going to get from IronRidge are all these connectors, like this guy, the rail connectors, and all the rails. and everything you need to fasten your panels down. That's the IronRidge racking system. So we'll take a little closer look at that in a minute. I'm going to do a 4 up, 4 in parallel, 3 in series. That's how it's going to be laid out on this is how it's going to be wired schematically. Some more details about how it's in the ground. I want a 30-degree angle because of my latitude, and I would go higher angle than that if I wanted to max out the amount of power, but like I said, in the summertime I got plenty of power. So I really want to use this more in the wintertime, so I'm going to lower my angle a little bit down to 30. I think that'll serve me better. So it just shows, you know, how high each post has to be, how deep it has to be into the ground, the size of the holes. Notice there's a space under each pole where you got concrete under the pole. So you're not just dropping that in the ground. There's a space under it. 6 feet deep, 1 foot 8 inches in diameter. They're 7 foot 6 apart and 12 foot spaced this way. So 12 feet here, 7-6 here. This is just for my situation. 3 foot 10 overhang. Now all this stuff goes through a design assistant on IronRidge's site, and they check it, all the engineering for the wind loading, the uplifts, and they make sure that I have everything I need, the sizing, all the connections, that this thing will withstand 130 mile an hour, hurricane force winds, because we're in hurricane land. So you'd plug in all your own information and it would tell you what you need. These are just more details on the components. The rails are XR 1000, 100, and the 10. The 1000s are more for ground mount. That's what I'm using. The 100s and the 10s are more for roof racking. They're just smaller. These things aren't cheap, but they're strong, and all the engineering's done. It should do what it's supposed to do. Okay, so like I said, you get your own pipe. This is not tubing. This is structural steel, Schedule 40, hot roll pipe. It's heavy, it's expensive. 3-inch diameter. Only thing I don't like about it is it rusts. This is the combiner box. It's just a look inside and out here. Now this will take up to 6 breakers, 150 volt breakers, or 3 of the 300 volt breakers, because if you do a 300 volt breaker, it's basically a double. So you put 2 of these together, you get a 300 volt. So 6 150s or 3 300s. It's just on the charge controllers, the PT100. Here are the specs, 200 volts plus the battery voltage. So the max voltage you can put into it's like 240, but it won't run at that voltage. It'll kick off at 187. You'll find that if you're close to that, you can sometimes, this happens to me twice a year, when I have a real cold morning and real bright sun, it's the perfect angle, it'll just crank up to about 191 volts, and then my system will shut off for about half an hour while it warms up. But not a big deal, twice a year. But it is a design point. If you're always over it, your system's never going to run. But that's what that spreadsheet's for. Okay. And just more details on that. That brings us to the final part here, the bill of materials. So I went ahead and listed every part number and every part with the cost of what I got. So if you want to duplicate this thing, you could just copy it right down the line. So I got 12 of the panels. I paid $220 each. You could probably get them cheaper now. The combiner box, $100. The surge protector is $100. All this stuff is expensive, but you need it. You can skip some things, but then if you have a surge, you're going to mess up your whole system. So I don't cut corners on these things. The PT100 charge controller. These have gone up in price since 4 years ago. I paid about $100 less. Back then, here's your whole racking system. I won't go through all that, but you see all the different little things you need. Big things and little things. It's good to get all these wire clips. They're cheap, like $9, and get everything tied up right, which we'll try and do. On the wire, I got 4 of these 50-foot wires. These are for hooking up the panels with the MC4 connectors. Now, you need 8 wires, so why do I only have 4? Because you're going to cut these in half. Not necessarily directly in half. You got to think about this a little bit. I'm not going to get into all that, but you know, you might cut one 40-foot and 10-foot, depending on what you actually need. You mix and match them, then you don't waste any wire. And so your MC4 connector goes on the panel side, and then the opened in will go in your combiner box. All right, number 3 wire, I'm just upgrading something I think I should have done the first time I built it. I used a 6 wire, and I'm going to go to a number 3. That's from the charge controller out. All right, breakers. We got from the PV into the controller. That's at the end of the 130-foot wire. There should be about 38 amps in there max. So I got a 50 amp breaker, and it's number 6 wire. Charge controller out. That's 100 amps because we're at a lower voltage now. It'll probably be at about 56 volts. Typically when you're charging. 15 amp DIN rails, that goes in the combiner box. And I got 4 of them, and I'm using the 15s. You could use the 20s, but the 15s, you know, yeah, they might trip once in a while. I've actually never tripped one, but if you did, it's no big deal, you know. But if you had a 20 amp breaker and you burn a wire, that's a big deal. So I'd rather have the smaller breakers. I got the pipe. Shipping and handling, got some discounts. It's $5,800. If you pay taxes, you get a tax break, tax credit, actually. You know, 30%. So it might be 28% now, actually. So anyway, it was $4,061. That's less than $1 a watt. It's pretty nice to be able to add, you know, a whole 4,000 watts for $1 a watt. So that'll definitely pay off. I'm looking forward to getting started on actually building this thing. So hope you guys will tag along for that. Thanks for watching. We'll see you on the next one.